Okay, sorry, they made an announcement. So if you look, these are called slope triangles, or rate of change triangles. Remember, rate of change is the same thing as slope. So rate of change and slope are the same thing. So this is called a slope triangle. It's telling you slope triangle tells or shows the rise. So notice, how much is it going up? Rising, like standing up. And we call it how much it runs. So rise over run. So rise over run is our slope. And you probably want to highlight that, rise over run. That's a huge thing. Notice we were saying it's however many feet per second. You wouldn't want to do it the other way. You don't want to say second per feet. That doesn't make sense. So you always put the Y, or the one that's going up and down, over the one that's going this way. Whether this was feet per second or floors per second, or I can't think of another example right now, but you always are going to put it rise over run. Slope is always set up rise over run. Okay, so we have a lot of things there. Initial value, slope is, or rate of change. So slope, you can also call this rate of change. Rate of change. Those are the two vocabulary words that we've now, oh, and linear, sorry, here's another word for you. Linear is constant rate of change. So if you would like to highlight all of your vocabulary words so that you know what to look for, you can highlight linear, you can highlight initial value, and you can highlight slope and rate of change. Those are all vocabulary words that I just covered. Okay? All right, let's do this one now. Sorry, my voice. All right, so we're still talking about a skateboarder. So we're going to pull these points. Notice it goes from 0 to 8. Well, there are 1, 2, 3, 4, 5, 6, 7, 8 lines. So each of those lines is actually worth 1. Oops. And then it goes from 0 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of those are worth 1 as well. Okay, so let's go ahead and write our points. So the first point is at 0 and a distance of 8. The next point is at a time of 4 and a distance of 6. Then we have 8 and a distance of 4. Then we have 10 and a distance of 3. Okay, let's find again the rise over run. So 1, 2. So it went down 2. Remember to show that it's going down, use a negative. Over here, that would be this right here. So from 8 to 6, that went down 2. Make sure that you show it went down. So from 8 to 6, if you think about it, it's going down 2. And then let's go over. So we have 1, 2, 3, 4. From 0 to 4, that goes up 4. Remember that vocabulary word that we just wrote down? And oh my goodness.
Good morning.
Okay, So remember from your vocabulary word how you need to set that up. So you would do rise, because we're doing feet per second. So it'd be -2 feet over 4 seconds. And again, you want to type that in. So I'm going to do -2. Notice the negative is right down here. So negative 2 divided by 4 is -0.5, -0.5 feet per second. Okay, let's do the next one, and I'm going to switch colors so that you can see which one is going to which one. So we're going to go from 6 down to 4. So 1, 2, so it's still going down 2, and it's going over 1, 2, 3, 4. So again, from 4 to 8, that changes by 4. From 6 to 4, that goes down 2. So I'm going to again set it up -2 feet for 4 seconds. And so again, that would be -0.5 feet per second. Okay, now this last one. Notice it looks a little smaller. So it's going from 4 to 2. So it's going to go down 1. Oh, sorry, hold on. Let's look at that again. So notice, and it's kind of hard to see it on this graph, that's why the table might be easier. So it's at 4, and then it's at 3. So it's actually only going down 1. From 4 to 3, it went down 1. And then from 8 to 10, that actually only changes by 2. 8 to 10 is 2. So then when I set this up, I would set it up as 1 foot over 2 seconds. Now, it looks like it wouldn't be constant. Remember we were talking over here about constant rate, which makes it linear. But notice this is a straight line. But when you type in -1 divided by 2, -1 divided by 2, you get -0.5 feet per second. So -1 over 2 is -0.5 feet per second. So notice it is actually constant. It's just that they put these points further apart. So this is further apart than this. But they're still on that same line. So notice these slope triangles look different, but I could have put a point in here and it would have made it the same. Because if it was going down 2 feet in 4 seconds, then if I only went 2 seconds, it would be going, if I went half that, it would go down 1 over 2. So it's still a constant rate or linear because all of these are the same. Sorry, my throat. All right. Now I want you to see if you can answer these on your own. So pause the video, and then I'm going to go through them. Segment blank shows a rate of change of 0. Well, we know that that's a rate of change of 0 because it's moving 0 feet per second. So B. Segment blank shows a negative rate of change. Well, that would be A because it's going down. Segment blank shows a positive rate. That would be C. From segment A, Terrence's rate of change for the first 2 seconds was blank feet per second. So for the first 2 seconds, we also call this from an interval. So from 0 to 2, his rate was going down 1, 2, down 2 over 1. So that would be -2 feet per second. And then segment C, so the last 5 seconds, or the interval 5 to 10, from 5 to 10 it was going up 1, 2 and over 1, 2, 3, 4, 5. So notice it's going up 2 and going over 5. You could write it as 2/5, or you could give the decimal, which is 0.4 feet per second. You need to be familiar with either leaving it as a fraction in this case or leaving it like that. This one, sometimes you'll see it left as 1/2, sometimes you'll see it as 0.5, so you need to be familiar with having it be 2 over 5 or 0.4.